We used AI to render this scene. We're going to also use AI to bring it alive. Today we're announcing NVIDIA ACE Avatar Cloud Engine that is designed for animating to bringing a digital avatar to life. It has several characteristics, several capabilities: speech recognition, text-to-speech, natural language understanding, basically a large language model, and using the sound that you will be generating with your voice, animate the face. And using the sound and the expression that you're saying, animate your gestures. All of this is completely trained by AI. We have a service that includes pre-trained models that you can come, developers can come and modify and enhance for your own application, for your own story, because every game has a different story. And then you can deploy it in the cloud or deploy it on your device. Has a great back end, has a TensorRT. TensorRT is NVIDIA's deep learning optimizing compiler, and you could deploy it on NVIDIA GPUs as well as output Onyx and industry standard back end so that you can run it on any device. Let's take a look at this scene in just a second, but let me first tell you about it. It is completely rendered with ray tracing. Notice the beautiful lights. So many different lights, and all of the different lights are projecting light from that source. So you have all kinds of direct lights. You have global illumination. You're going to see incredibly beautiful shadows and physics simulation. And notice the character, the beautiful rendering of the character. Everything is done in Unreal Engine 5. We partnered with an avatar framework, an avatar tool maker called ConvAI. And together, we developed this demo you're about to see. Okay, run it, please. Everything is real time.
Hey, Jen. How are you?
Unfortunately, not so good.
How come?
I am worried about the crime around here. It's gotten bad lately. My ramen shop got caught in the crossfire.
Can I help?
If you want to do something about this, I have heard rumors that the powerful crime lord Kuman Aoki is causing all sorts of chaos in the city. He may be the root of this violence.
I'll talk to him. Where can I find him?
I have heard he hangs out in the underground fight clubs on the city's east side. Try there.
Okay, I'll go.
Be careful, Kai.
None of that conversation was scripted. We gave that AI, this Jin AI character, a backstory. His story about his ramen shop and the story of this game. And all you have to do is go up and talk to this character. And because this character has been infused with artificial intelligence and large language models, it can interact with you, understand your meaning, and interact with you in a really reasonable way. All of the facial animation completely done by the AI. We have made it possible for all kinds of characters to be generated. They're all domain, they have their own domain knowledge. You can customize it, so everybody's game's different. And look how wonderfully beautiful they are and natural they are. This is the future of video games. Not only will AI contribute to the rendering and the synthesis of the environment, AI will also animate the characters. AI will be a very big part of the future of video games. The most important computer of our generation is unquestionably the IBM System 360. This computer revolutionized several things. The first computer in history to introduce the concept of a central processing unit, the CPU, virtual memory, expandable I/O, multitasking, the ability to scale this computer for different applications across different computing ranges. And one of the most important contributions and one of its greatest insights is the importance of preserving software investment. The software ran across the entire range of computers, and it ran across multiple generations. So that the software you develop, IBM recognized the importance of software, recognized the importance of preserving your investment, and very importantly, recognized the importance of installed base. This computer revolutionized not only computing, and many of us grew up reading the manuals of this computer to understand how computer architecture worked, to even learn about DMA for the very first time. This computer not only revolutionized computing, it revolutionized the thinking of the computer industry. System 360 and the programming model of System 360 has largely retained until today. 60 years. In 60 years, $1 trillion worth of the world's data center all basically used the computing model that was innovated all the way 60 years ago until now. There are two fundamental transitions happening in the computer industry today. All of you are deep within it, and you feel it. There are two fundamental trends. The first trend is because CPU scaling has ended. The ability to get 10 times more performance every 5 years has ended. The ability to get 10 times more performance every 5 years at the same cost is the reason why computers are so fast today. The ability to sustain 10 times more computing every 5 years without increase in power is the reason why the world's data center hasn't consumed so much more power on Earth. That trend has ended, and we need a new computing approach, and accelerated computing is the path forward. It happened at exactly the time when a new way of doing software was discovered, deep learning. These two events came together and is driving computing today. Accelerated computing and generative AI. This way of doing software, this way of doing computation, is a reinvention from the ground up, and it's not easy. Accelerated computing is a full stack problem. It's not as easy as general purpose computing. The CPU is a miracle. High-level programming languages, great compilers, almost anybody could write reasonably good programs because the CPU is so flexible. However, its ability to continue to scale and performance has ended, and we need a new approach. Accelerated computing is full stack. You have to re-engineer everything from the top down and from the bottom up, from the chip to the system software, new algorithms, and of course, optimizing the applications. The second is that it's a data center scale problem. And the reason why it's a data center scale problem is today, the data center is the computer. Unlike the past when your PC was a computer or the phone was a computer, today your data center is the computer. The application runs across the entire data center. And therefore, it's vital that you have to understand how to optimize the chips, the compute, the software across the NIC, the switch, all the way to the other end in a distributed computing way. And the third, accelerated computing is multi-domain. It's domain-specific. The algorithms and the software stacks that you create for computational biology and the software stack you create for computational fluid dynamics are fundamentally different. Each one of these domains of science need their own stack, which is the reason why accelerated computing has taken us nearly 3 decades to accomplish.